Find the complete integral of this equation. So for this I am taking f to be equal to, I take qz to the other side because we need to apply the Charpit subsidiary equations. For that we need all these details. So what is fx? It is derivative of f with respect to x. Because there is no x here, so derivative of f with respect to x is 0. Fy, now derivating f with respect to y. So this is p square plus q square. And fz, derivating f with respect to z, I am having here minus q. Then fp becomes 2py and fq is equal to, it is 2qy minus z. And now using all these details into the Charpit subsidiary equations, so dx divided by fp, that is 2py, equals to dy divided by fq, that is 2qy minus z. And then dz divided by p multiplied with fp. So multiplying p here, we get, this is your fp, right? So this is 2p square y plus q multiplied with fq. So this is 2q square y minus qz. We can also write this as, if I take 2 common, so if I take 2y outside, we have p square plus q square in the bracket minus qz. And then this is further equal to dp divided by negative of fx. Fx we know it is 0 plus p multiplied with fz. What is fz? It is minus q. So p multiplied with minus q, that becomes positive pq. And then dq divided by minus of fy. Sum of p square and q square plus q multiplied with fz. Fz is negative q. So this will be minus q square. These two cancelled out and we have here minus p square. Now we need to choose the ratios for which we can get the value of p, q, or the relation between these two. So what ratio is easier to solve? We need to choose two ratios. Let me take these two ratios because in the denominator I am having here p common, so I am cancelling these two and we have, so that is p dp equal to minus q dq, or p dp plus q dq equals to 0. Integrating, we get p square by 2 plus q square by 2 equals to the constant a. So that is equal to p square plus q square equal to twice of a. Let me take this constant to be equal to a dash square because I am having square over here. So just to have the symmetry, I am writing here a dash square as the constant. So where a dash square, that is equal to 2a, is a constant. It is easier to solve further if I am having square with the constant as the power. So we have got the relationship between p and q to be p square plus q square equal to a dash square. How to get the value of p and q now? We are going to use the given equation. This one, this is your given equation. Let's use this equation. So this is the given equation and we have the relation to be p square plus q square equal to a dash square. Let's put this value of the sum of p square and q square in this given equation. So we get a dash square y equals to qz, or it is equal to q equal to a dash square y divided by z. To get the value of p, I am going to put this value in the given equation, the value of q in the given equation. So from the given equation we have p square plus q square. So we have this to be a dash the power 4 y the power 2 divided by z square into y equals to q into z. Into z, z cancelled out, and this y is also cancelled out from both the sides. So we have now p square to be equal to, I'm taking this term to the other side, so this is equal to p equal to the square root of, okay, let me take a dash square outside of the square root. So we have got this to be the value of p. To get the value of the complete integral, we use the equation dz equal to p dx plus q dy. And now putting the value of p and q over here, adjusting this z to the numerator of the left hand side and taking this term to the left hand side. We can write this further as, because when integrating with respect to x, this is constant for x, right? When integrating with respect to x, this becomes constant. So I am taking this constant to the denominator of the left hand side. So let me write here z square under root of z square minus a dash square y square and is equal to a dash dx. Now how can I write this numerator to be? I know I am having z dz and y dy, right? So for that, let me write this as the derivative of z square minus a dash square y square. It is 2z dz minus a dash square 2y dy. I'm already having z dz and y dy, right? And also a dash square is multiplied with this. What extra I need? I need to have 2 multiplied with them. So let me multiply and divide by 2 first. And then I write this numerator to be this. And now integrating both the sides, we need to integrate with respect to this z square minus a dash square y square. So from that we get square root of z square minus a dash square y square and is equal to, this will be a dash x plus the constant b, where b is a constant, right? And when taking the square on both the sides, we get z square minus a dash square y square equal to a square x square plus b square, okay, ax plus b whole square. So from here we get z square to be equal to a dash square y square plus ax plus b whole square to be the required complete integral. So this is the required complete integral of the given equation, right? So by getting the value of z, we have this to be the required complete integral. Alright, stay blessed.